Hello everyone. I've wanted to check out the new Miller Thunderbolt welders for a while now, and I'm finally getting around to it. It's interesting for me because it's Miller's cheapest welder by far, and it's made in China. But despite being the cheapest Miller, it's still quite a bit more expensive than something like a Yeswelder or an Amoco. I've heard some say that since they're all made in China anyway, there's really no difference, so why bother paying for the name? The Thunderbolt 160 is a very basic welder with modest output and duty cycle, so it initially could seem like the name alone is driving up the cost. So I thought it might be fun to compare a made-in-China Miller to a Chinese brand welder with similar features to see if you're getting anything other than the name for the increased cost. Interestingly, when I was doing some research before this video, I discovered that Amoco Power's website seems to have disappeared. I can still find Amoco welders for sale at lots of places online, but searches for the company return almost nothing beyond references to a wholesaler based in California. I always found certain aspects of the old Amoco website a bit questionable, such as the stock pictures of large buildings and fancy lobbies with an Amoco logo photoshopped onto them. And the only address listed on their old site came up in an apartment block. But regardless, their site has now vanished, and I didn't want to compare the Miller to an Amoco, so I'll be comparing it to a Yeswelder Arc 205 DS. So far, Yeswelder responds to support questions, and they have a website, so there's that. Although the address on the Yeswelder website is actually that of a company that you can pay $35 a year to use their address for your business, and they will just scan and upload any documents that they receive for you. If you search that address online, you'll find dozens of companies, foreign and domestic, that list that address as their business address. Not saying that's a problem, it's just not like Yeswelder actually has a physical location in Colorado. The rest of the Yeswelder website is pretty light on company info. The only thing you get other than that virtual company address is a very surface fluff about page, and that's pretty much it. Don't know if that means anything, just saying. But moving on, this is the Thunderbolt 160, which is a dual voltage machine that maxes out at just 80 amps on 120 volts and at 160 amps on 240 volts. By comparison, the specified output of the Yeswelder is 130 amps on 120 volts and 205 amps on 240 volts. The duty cycle of the Miller is rated at 20% at 65 amps when running on 120 volts, and 30% at 160 amps when running on 240 volts. According to the graph on the spec sheet, when running on 240 volts, the Miller should have close to a 50% duty cycle at 125 amps, and that should be plenty for most people, honestly. With beveling and multipass, you can weld just about anything with a 1/8 7018 rod at 125 amps. And a 50% duty cycle would mean you're welding 5 out of every 10 minutes, and considering that most projects are going to involve fit up and positioning things and that kind of stuff, it's doubtful that the average user will need more than that. But it's still definitely not an industrial or production level output or duty cycle. The Yeswelder, on the other hand, claims a 60% duty cycle at 205 amps on 240 volts and a 60% duty cycle at 130 amps on 120 volts. Most of the Chinese brand welders list super high duty cycles like this. Maybe they really do have industrial duty cycles, or maybe they overrate them. If they are overrated, it may be that they're not worried about long-term reliability, or it may be that they just figure most people won't run them nearly that hard anyway, which is probably true. It could be any of those things or a combination, but I think it also could just be due to the fact that they aren't constrained by any certification testing from standards organizations. Interestingly, the data tag on the Yeswelder shows the number for the IEC standard for arc welding power supplies. I have to imagine that's just because the data tag follows the format of that standard, but not that the welder was actually tested to that standard. I seriously doubt that this Yeswelder would pass if actually submitted for certification. The power cord alone seems like it would cause the welder to fail testing because it uses a standard NEMA 5-15P, which is a 125 volt rated plug. But they include an adapter which directly connects that plug to 240 volts. The 60974-1 standard also has requirements for how accurately the output must match the setting, has requirements for insulation and conductor ratings of all the cables and the internals. It has minimum standards for any included welding cables, standards for the power switch ratings and endurance testing of the power switch, and a lot more. But I brought this up primarily due to how it relates to duty cycle. The 60974-1 also has multiple testing requirements and build requirements based on the duty cycle, as well as the effective current draw, which is directly tied to duty cycle. Rating a machine at higher duty cycle means it has to be tested at higher levels. It also means a higher effective amp draw, because the effective amp draw is kind of an average between the maximum draw when running at the max duty cycle, averaged out with the zero draw of the resting period. So a higher duty cycle will really ramp up the effective amp draw. And that means more strict requirements for everything in the supply chain. There are also limits for temperature rise of certain components during testing, and obviously those numbers will be more difficult to maintain if it's tested at a higher duty cycle. If a company like Yeswelder isn't having the design of their models certified, then they could theoretically rate them at whatever duty cycle they want. On the other hand, the Thunderbolt 160 is tested and listed by Intertek as conforming to the ANSI, IEC, and CSA 60974-1 standards. So Miller had to ensure that the design would pass all required testing and inspections based on the output and duty cycle rating that they give it. Sorry, I know that's a lot of rambling about stuff that won't matter to most people. The point is, the duty cycle rating of the Thunderbolt 160 seems quite low in comparison to just about any Chinese brand welder. But I would guess that there's a lot more purpose and reasoning behind that rating than there is behind the 60% rating of the Yeswelder. None of this guarantees that one or the other will hold up better long term if you often push them to their respective duty cycles. But it may help explain at least one consideration that may go into a particular duty cycle rating. Both of these are very basic welders. Just set your amperage and that's it. Both of them claim to have a hot start feature, but neither of them are adjustable, nor do they have adjustable arc force. They are just about as simple as stick welders get. As for accessories, the Miller includes a very basic work clamp. It's stamped steel, there's no copper jaw, no braided strap, but it does have a very stiff spring, and it's built sturdy enough, so it's not the worst clamp I've seen. But it's nothing special. The work clamp that comes with the Yeswelder has a braided strap between the two sides, but the jaws are just copper-plated steel, and the body of the clamp is very thin and flimsy. I wouldn't expect the Yeswelder clamp to hold up as well as the one with the Miller. The two electrode holders look remarkably similar, but they are very different internally. The Miller is all cast copper inside with two cable set screws for a strong connection. It looks basic, but the guts are decent. And it is much better than what comes with the Yeswelder, which is all just copper-plated stamped steel inside, including the jaws. The cables themselves are about 10 feet long on each machine, and the Miller cables have copper conductors and the insulation on them is decent. They're nothing amazing, but they're totally fine. The cables that come with the Yeswelders and all the Amico welders that I've tried have insulation that gets very soft if the cables heat up at all, and it melts fairly easily. I've also discovered that they have copper-plated aluminum conductors rather than actual copper. And when compared to copper, aluminum isn't as durable and it cannot handle as much current for a given size. So overall, the accessories that come with the Miller are cheap, but they are much better where it counts compared to the Yeswelder stuff. Now let's take these machines apart and see what they look like inside. I've pulled both machines apart and given them a look over, and I found an actual issue with the Yeswelder. There is a stray splash of solder that is shorting out this capacitor on the board. I've already powered the welder on, but I haven't welded with it yet, so hopefully that short didn't cause any damage. I'm going to fix that before I power it up again. I also found a perfect example of why this Yeswelder wouldn't pass certification testing. The power switch is rated at 25 amps, but the effective current draw of this welder is 29.4 amps. The Miller also has a 25 amp rated power switch, but the effective current draw of that welder is only 15 amps because of the lower output and duty cycle. The power switch isn't that big of a deal, but it clearly shows that the Arc 205DS was not built and rated with the goal of meeting that 60974-1 standard that is on the data tag. There's a whole lot more to that standard, and I'm not going to go in depth checking out whether it would or wouldn't meet all of it. The power switch was just one obvious example that I thought I'd point out. Another thing I found in the Yeswelder is this little daughter board, and it says ZX7200 on it, which just so happens to be the model name of another small welder I've reviewed in the past. In general, I like the layout of the Miller much better, with all of the high voltage stuff being further from the case and just better isolated in general. The capacitors in the Miller aren't a top tier brand, but they are a more well-known brand than what's in the Yeswelder, and they have better specs. The large caps in the Yeswelder are rated at 200 volts and 85 C. That voltage rating doesn't leave much headroom for a safety margin. The large caps in the Miller are rated at 250 volts and 105 C. The caps in the Miller are also right in the airflow path from the fan, while the capacitors in the Yeswelder are above some of the hot components and not really in the path of the airflow. Heat kills capacitors. Even if the max temp isn't exceeded, a capacitor's life will be shorter the hotter it runs. There also seem to be no provisions to bleed down the capacitors in the Yeswelder. Fortunately, the output doesn't stay live, but multiple areas of the board remain live at around 170 volts when the welder is turned off and unplugged. So that's a good heads up to be careful when taking apart anything like this. You never know when you might run up against a charged capacitor. The large caps in the Miller have bleed down resistors across them, so they should discharge fairly quick once you turn it off. But you still should use care around them. The Miller has a larger transformer, and it's mounted separately from the board and wired in with bolted conductors rather than relying on solder reinforced traces on the board like the Yeswelder. Overall, the Miller is simply built better. We are talking about a $500 welder versus a $150 welder, so it's not surprising that there are differences. But so far, it's pretty clear that it's not just a difference of what name is on the side. Built in China or not, you're clearly getting something extra for the money beyond just the name. There are real, tangible quality differences. Now I'll get them back together and see how they perform. First up is the Arc 205DS. It runs just fine. Arc starts aren't bad, and the arc is smooth. Unfortunately, despite what the website and the ad says, this machine does not run 6010 rods. I tried on 120 volts and 240 volts. The arc constantly goes out. If I really kept the rod crammed into the puddle, the arc would stay going for a bit, but it would still sputter and go out occasionally. That's not too surprising because many inverters have trouble running 6010, but it's disappointing considering that the website says that this welder is great for 6010 in one spot and that it's ideal for 6010 just below that. Strangely, the website also says that it has lift start for TIG, and that's not correct either. So it seems they need to update the description on their website. When running on 240 volts, it maxes out at just over 160 amps, despite the display showing 210 amps. It pulls just over 30 amps from the wall at max output. The display gets slightly more accurate as you turn the amperage down. When set at 155 amps, you get about 122 amps, and when set at 100, you get a little under 90. The same situation continues when running on 120 volts. On 120 volts, the setting goes to 147, which is actually far more than the rating of 130 amps, but the actual output is only 115 amps. At that point, it will run a 1/8 7018, but it somehow manages to pull almost 50 amps of current from the circuit it's connected to. So the Arc 205DS doesn't provide the max amperage it claims in the specs, and it would trip a breaker awful quick if you ran it at max output on 120 volts for very long. And by very long, I mean more than 5 or 10 seconds. High current draw on 120 volts aside, the output isn't bad, particularly in a welder this small. It's just a shame that it won't reach nearly the output they claim because it really rubs me wrong when a product has misleading or straight up false specs in the marketing. Maybe Yeswelder themselves are just being misled by whoever is actually manufacturing the machines for them. Hopefully they'll weed out the issues and improve their product lines, but I'm getting strong vibes that Yeswelder is just the latest company that has cropped up, invented an origin story that claims to have been manufacturing equipment for 15 years, but is really just the latest name to be painted on the same generic machines that are being cranked out with a dozen different brand names on them. Prove me wrong, Yeswelder. Correct the claims on your website and get whoever manufactures these things for you to correct their specs and ratings. Ironically, the two machines ended up having almost identical output on 240 volts. When maxed out, the Miller gives about 161 amps. I found the settings on the dial to be pretty accurate at various settings. Arc starts are relatively easy and it runs smooth. I think there may be some sort of anti-stick or arc force feature going on because the amperage fluctuates by a few amps. I didn't notice any odd behavior in the arc, but the amp gauge clearly shows small, intermittent rises in amperage. Output on 120 volts is fairly low at 80 amps, but it will run a 332nd 7018, and it draws only 23 amps or so, so it should be fine on a typical 20 amp breaker. On the spec sheet, Miller also claims ideal performance for most 6010 rods. I wouldn't call the Thunderbolt 160's performance with 6010 ideal. To be fair, the spec sheet does say they don't recommend 6010 for open root welding, which I think is code for 6010 performance isn't actually ideal. 6010 was usable if I was careful, but I personally wouldn't buy this welder specifically to run 6010. It runs it, but it's finicky. Keep in mind, I'm far from an expert with 6010, but with some other welders I've tried, I can get stupid and wild with the rod manipulation and long arcing, and a 6010 will just keep burning. Not so much with the Thunderbolt because the arc will go out very easily if you're not very careful and consistent. I wish Miller would tame down the ideal performance wording in their marketing materials for this welder. Overall, for most rods, both of these welders work fine. But after really digging into it, it's clear that there are very real quality differences. Even something as simple as the fasteners that hold the cases together illustrate the difference. The Miller has proper fine thread bolts that screw into proper threads in the frame versus the little sheet metal screws on the Yeswelder. Obviously, this is a tiny, insignificant detail that really doesn't matter in the grand scheme of things. But it's just a small example of the differences that you can find all over these welders, inside and out. And that's not to mention that the Thunderbolt has Miller's 3-year warranty with 5 years on the main rectifier components. And I have a local welding supply shop where I can drop it off for warranty service if I have any problems, so that definitely adds value. I'm not trying to convince you to go out and buy the Miller. Some people will likely still pick the Yeswelder due to the low cost, and that's fine. But it's obvious that there is a whole lot more to the price difference than just the name alone. I know this one was a bit long-winded, so hopefully it was helpful. If you have any questions, or if there's anything else you'd like me to test out with either of these machines, let me know. And as always, thanks for watching. Take care.